And now we have this question number 3 on the board, okay? We are to find the value of a and b, for which ax raised to the power 3 plus bx raised to the power 2 minus 4x plus 4 is divisible by x minus 1 and x plus 2, and hence determine the third factor. You would recall that I stated in previous videos that whenever you hear the word that a polynomial is divisible by certain factors or by a given divisor, it simply means that that divisor is a factor of the polynomial. And that goes to mean again that you are to use factor theorem, where if you substitute for the variable in that polynomial, your remainder is expected to be what? 0. So we're going to apply the same knowledge here. That the question said that this polynomial is divisible by x minus 1 and x plus 2 simply shows that x minus 1 and x plus 2 are factors of the polynomial. So we are going to go straight ahead and obtain the value of x from this factor and x from this factor, substitute into this polynomial, create two equations and solve them simultaneously. That's just the thing. That will give us the value of a and b. Let's see how it goes. I'll start with the first divisor. Let x minus 1 equal to 0. Of course, it implies that x is equal to 1. So what do you do from here? Go to the polynomial. Wherever you see x, fix in that 1 you got there. Are you ready? Come along with me. Let's do this, please. So this is going to be, I'll come over here. This is the polynomial. So I have a times x is 1. So you fix 1 there, raised to the power 3. And then plus b, x is 1, raised to the power 2, minus 4, x is 1, then plus 4. I've substituted the value of x here. So what do I expect to get? The remainder will be equal to 0, according to factor theorem. So I'm going to make this equal to what? 0. Let's quickly simplify this. 1 raised to the power 3 is 1 times a will give us a, plus 1 raised to the power 2 is 1 times b will give us b. Then look at this. Minus 4 times 1 will give us minus 4. Minus 4. So minus 4 plus 4 equal to what? 0. You see that a plus b would give us equal to 0 because minus 4 plus 4 would give us 0. They will just cancel off to give us 0. Is that okay? Now, this simply implies that a is equal to minus b. And we cannot get a from here, we cannot get b from here because this is one equation containing two unknowns. We call it equation 1. Then proceed to see how we can use this second divisor to obtain equation 2. So I'll write also, let x plus 2 be equal to 0, which implies that x value there is minus 2. You substitute that into the polynomial, so it means that we're going to get a bracket x is minus 2, so we're going to fix in minus 2 raised to the power 3, and then plus b, x is minus 2 raised to the power 2 minus 4, open bracket, minus 2, then plus 4. Once again, according to factor theorem, the remainder expected will be 0. Minus 2 raised to the power 3 will give us minus 8. That 3 there is an odd number. A negative number raised to an odd number will produce a negative result of that thing. So minus 8 times a will give us minus 8a. Then here will give us minus, okay, now it's going to be plus minus 2 raised to the power 2. 2 is an even power. A negative number raised to an even power, the final result will become positive. So this is plus 4 times b will give us plus 4b. This term will give us minus 4 times minus 2, which is plus 8. Plus 8 plus 4 equal to 0. You take note that this will give us minus 8a plus 4b, then equal to minus 12. 8 plus 4 is 12. That 12 moves over to the right hand side, it becomes minus 12. You can choose to reduce this term if you want. 4 is common to them. So I can say or, divide everything here through by 4. Okay, let's say you use minus 4 to divide, or if you still want to use 4, is your choice. Okay, let me use minus 4 so that this will become positive. Minus 4 divides this term, you're going to get 2a. Is that okay? So, or divide through, let me indicate, divide through by minus 4. So this will give us plus 2a. Divide this plus 4b by minus 4, you're going to get minus b. Divide minus 12 by minus 4, you would get plus 3. So this proper equation 2. At this point, we're now going to solve equation 1 and 2 simultaneously. So solve equation 1 and 2 simultaneously. If we do that, what are we going to get from equation 1? From equation 1, we know that a is equal to minus b. So I would put a equal to minus b in equation 2. Since we got that from equation 1, are you getting? You now need to substitute that value in equation 2. So this implies that 2 bracket in place of a, I'm going to put minus b, because that's what the value of a is from equation 1. So subtract b from it, look at that, and everything will be equal to 3. 2 times minus b would give us minus 2b. Minus 2b minus b will give us minus 3b equal to 3. Now take note that the value of b from here will be equal to minus 1 if you divide through by minus 3. We've obtained the value of b, so we're going to say put b equal to minus 1. Minus 1 in equation 1 or 2. Now it's your choice. You can either use equation 1 to get the value of a, or you can use equation 2 to get the value of a. Just imagine you're in an exam, or which one do you think will be faster for you to get your result? Of course, the one with fewer terms, which is equation 1. On your own place, substitute b equal to minus 1 in equation 2 also, and see that you get the same result we are going to obtain using equation 1. So I'm going to write using equation 1, and then this implies that a is equal to minus, and b has the value minus 1. Minus 1. Alright? So that's what we are going to get. Therefore, we now see that the value of a is equal to plus 1. We've gotten a and b. Let's go for a short break. When we come back, we'll fix in the value of a and b into this polynomial. Then we'll use these two polynomials to determine the third factors. This time around, I want to obtain the third factor of this polynomial, being that we've obtained the value of a and the value of b previously. Before the short break, the value of a is 1, the value of b is what? Minus 1. So from here, so it means that p of x, the polynomial, is that okay? Will be equal to, in place of a, you put 1. If you put 1 there, you multiply by this x cubed, you're going to get x cubed. Then in place of this b, you put minus 1. This will now become plus times minus 1 x squared. And plus times minus will give you what? Minus. So minus 1 times x squared, and 1 times anything will give you that thing. So this becomes x squared minus 4x plus 4. Good. This is a polynomial. We are to get the third factor. We don't know the third factor. Let me write. Let the third factor, which we do not know, be equal to x plus alpha. We don't know it. Is that okay? We know the two factors here given. Now let this be the third factor. You know, there's something about quadratic equation. Let me take your mind back to quadratic equation. If you're given a quadratic term and they give you the factors of that quadratic expression, if you multiply the two factors of the quadratic expression, you will get that quadratic expression. Is that not so? For example, if you're given x minus 5 bracket x plus 2 to be a factor of a given polynomial, which is a quadratic term per se, if you multiply out those two factors, you should get that quadratic expression. Now, on the board here, this is a problem of polynomial of degree 3. We have to get the third factor. We know two factors already. Of course, you know, being degree 3 polynomial, it will produce 3 factors for us. So, it is expected that if you multiply the 3 factors, you will get this polynomial. Look at it. Therefore, what do I do? It implies that x minus 1 times x plus 2 times this x plus alpha, which we are looking for, the unknown factor, would give us the polynomial x cubed minus x squared minus 4x plus 4. Does that make sense? Now, let me ask you a question. If you're given 2 times y equal to 6 and you're asked to find y, what do? Is it not to solve that y is equal to 6 over what? 2. You divide both sides by the coefficient of that thing you're looking for. So here we are looking for x plus alpha, and then it is multiplied by these two factors. It means that we are going to divide both sides by x minus alpha x plus x minus 1 and x plus 2, which are the factors of this x plus alpha, because we are looking for this x plus alpha. So we're going to write x plus alpha now is equal to x cubed minus x squared minus 4x plus 4. We're going to divide this by x minus 1 and then x plus 2. Is that okay? So at this point, we will obtain this factor. But first of all, you can multiply this out before you start dividing. This is going to give us x cubed minus x squared minus 4x plus 4 divided by, if you expand the denominator, you get x squared plus x minus 2. So from here, you can decide to use either a long division method to divide this and get the third factor, or you can use the Omaker's short division method to divide and get the third factor. In fact, all these processes is just to make you understand the concept. Ordinarily, I could have just said that the third factor is this polynomial divided by this straight ahead, and I'll start solving. Is that okay? Alright, so let us do that. I'd like to use the Omaker's short division method. I have a reason for choosing that method, so that you can be able to quickly get a value of polynomial division, especially when dealing with aspects of integration by polynomial. Is that okay? So let us move on using Omaker's short division method. Omaker's short division method. Let us see what this is going to give to us. So x plus alpha will now be equal to, are you ready? So we have x cubed minus x squared minus 4x plus 4 divided by x squared plus x minus 2. We've already done a lot on polynomial division before, so let's just move on. X cubed will be divided by this x squared. So let me cancel that out. And if it divides it, let's see what it's going to give to us. This is equal to x raised to power 3 divided by x raised to power 2 will give you x. So let me write it with red marker. What do you do with this x? When we treated this, we said you're going to use the x to multiply the other terms that didn't take part in the division process. Change the sign and then add it to its like term in the numerator. So I'll be fast in doing that. Let's go. X times this plus x will give us plus x squared. Change the sign of that plus x squared, you get minus x squared. So add it to the x squared on top. Minus x squared plus minus this x squared in the numerator. This will produce minus 2x squared for us. Is that okay? Then again, x times minus 2 give us minus 2x. Change the sign, you get plus 2x. Add it to the like term, minus 4x here. So plus 2x minus 4x, if you add them up, you are going to get minus 2x. You're going to get minus 2x. Alright, we've used this x to multiply these two terms that didn't take part in the process of division itself. So the next thing we're going to do is to repeat the process. The numerators now, this one produced this, so this is gone. This one will now have minus 2x squared. The highest degree of the remainder part here is this x squared. Now the denominator, the highest degree is also x squared, is that not so? So you can still divide. I'll come over here, minus 2x squared divided by this x squared. The result will give me what? Minus 2. Minus 2x squared divided by x squared, the result is minus 2. Use the minus 2 to multiply this plus x and change the sign. Minus 2 times plus x will give us minus 2x. Change the sign, you get plus 2x. Add it to the like term on top. The like term of x on top now is this, because this minus 4x produced this x term. Is that okay? So we've already gotten plus 2x from under when we change sign. Add it to this minus 2x. Plus 2x minus 2x will give us 0. Again, use this minus 2 to multiply this minus 2 this time around. You're going to get plus 4. Change the sign of that plus 4, you get minus 4. It does not contain any x. So add it to the term in the numerator that does not contain any x. Of course, it's plus 4. So minus 4 from under, then add it to the plus 4 on top. Minus 4 plus 4, this will produce 0. So you see that at the end of everything, our remainder here is what? 0, 0. Remainder is 0. Is that not so? That's what we obtained here. 0, 0. It simply tells us that this x plus alpha we are looking for is actually a factor of this polynomial. Remember factor theorem. Remainder is expected to be what? 0. Therefore, consider x plus alpha, the third factor. X plus alpha, the third factor. The third factor is x minus 2. So that's the solution to this problem.